I wanted to do this session to dive into patch reversal vulnerabilities, as I've been doing a lot more work around secure coding practices and stuff like that. And I've been, this is a whole new talk, a whole brand new thing I've been building to kind of educate us about this. So, without further ado, I am Liran. I'm a developer advocate at Snyk. I do a bunch of things around the community related to open source security, web security, and all those kind of things. If you want to do anything together, shout out at Twitter, and we can chat and talk about it. So as developers, right, we're kind of very aware of I think the general concern around application security. We're this is essentially the whole topic of this 24-hour live streams. So it's not new to anyone, I guess, joining here in terms of why it is important. You're seeing it in the news. You're reading about security incidents, supply chain attacks, cybersecurity, S-bombs, general stuff, right? You are aware of it. And what I'd like to do today is teach you a little bit about some concept related to a specific type of vulnerability called patch reversal, which it seems to an extent sometimes this is an insignificant security weakness, and we'll see in a sec maybe why. But it may have some very devastating consequences and impact on your applications, which is why I want to get into it. So by watching this session, hopefully, what we'll learn is new practices and that you could actually apply at your team, your work, whatever, your side projects, open source, whatever. But hopefully be able to build more secure web applications based on gaining these new secure coding skills, okay? So stay with me here. Now, we said patch reversal, and I've repeated that it's definitely a few times here, and it's going to be a repeating theme more obviously, but what is it, right? Let's define it for a second and understand what is patch reversal at all. So if we go by the dictionary definition for what patch reversal is, we're also known, by the way, as directory traversal. You see that it's related to, it's a sort of an attack that relates to user input that may come from insufficient security validation. So some input goes in to a system, code security concerns around insecure validation of user supplied file names, maybe, right? Which said input will actually take a different meaning, right? It will indicate maybe a different file path or something like that. So here we're basically kind of already calling out what this actually is. It's related vectors of attack to patch reversal vulnerabilities. So insufficient secure coding, it's kind of how it starts. And then the source of something would be maybe a user supplied file name, right? When they upload a picture somewhere on Twitter or LinkedIn or whatever, they kind of maybe control the image itself. Maybe the file name does, gets, swallowed as is to the app internals and so on. And that in turn used in the system itself. It needs to be saved as a specific maybe file name on a block disk or whatever. So that is essentially the technical terms in the security lingo, the source to sink. Okay, when that happens, the impact of that is essentially traversing maybe parent directories. So patch reversal vulnerability can happen because user inputs control the path, the URL, something like that. And that impact is that they are able to actually traverse the directory and expose different files. But not only that, and that is what I kind of want to show you, that's the bigger aspect of the impact here. So let's put it in practical terms and see what this actually means. In essence, an HTTP request that uses the .. characters, right, to traverse up the tree, you traverse the directory up to look up files and whatever, may result in essentially accessing arbitrary files on the system, right? You fire off this HTTP request for a config.json. And if you happen to be vulnerable to patch reversal vulnerabilities, which again may seem just inconvenience, right? Okay, so you can access some files, but what if those files are actually configuration files where you actually store API keys and credentials to databases and stuff like that? Some apps do have that. We can talk about whether that's there are better secure ways of doing it, but some apps definitely have those kind of sensitive files. And I'll show you why it's even more than potentially just the sensitive files that you have on disk that will actually get you in trouble. Here is the thing. While a patch reversal vulnerability or attack is kind of simple to execute, as we've seen, it's just basically an HTTP request, and it may look harmless or simple, its impact can actually be very devastating and far-reaching. two primary concerns that you should have in mind and be aware of is, first off, it has this implication, obviously, here of sensitive information exposure, right? Like, think about it for a second. I gave the example before of like /config JSON, which is, obviously you would be exposing a sensitive file. But really not just that. Like, what happens if I can actually access your package JSON, right, or your package look? I can actually look at which dependencies you have, and what if I can find another vector of attack, which would start from like a path traversal. You've just linked your package JSON, and I can find that there's like a vulnerable dependency there that has like remote or command injection vulnerability. So I can basically escalate my attack further out. Let's not talk about SSH keys and whatever. So like there's like a bunch of stuff that's like really bad if it happens. Not so long ago, Zimbra, this is a mail server that is often used by organizations, and it was found to be vulnerable to path traversal attacks. Now, these mail servers, as you could figure out, like people send out attachments. Maybe there's like some end system that does compression or decompression of like, zip and scan and whatever, all of those things happening. So you could understand that there's like, some kind of complexity in handling and like why maybe path traversal might be, relevant there. But specifically this vulnerability is interesting because it was, first of all, it's very recent. Like, this is from 2022, very recent vulnerability for this software and the software vendor itself. And it has been able to basically create an elevated impact that actually goes from a path traversal vulnerability into remote code execution. Now, CISA, an organization, a government organization, cybersecurity infrastructure and security agency, has actually put out alert to advise everyone to essentially like upgrade immediately to fixed versions. Okay, like this is very important. Path traversal vulnerabilities manifest and emerge in software like Apache, which has been there for for decades, as well as this vulnerability that was disclosed like just a couple of years ago. So it shows you how hard and complicated it is to actually write secure code. Right, secure code, as sometimes that could seem as simple as validating paths and enforcing them and all of those things. And what's really interesting with this CVE that was identified, first off, it's a critical level vulnerability in terms of the severity of it. Okay, so while that does not always mean risk, that is actually pretty important to understand still. It actually is important to learn about this one specifically because of how it emerged. So to prove kind of like the case of like how difficult it is to write secure software, we can for a second just like mention there that this vulnerability was actually happening due to an incomplete fix that was previously applied to like fix a different vulnerability, right? But it wasn't applied very well, so like now it's like still vulnerable. So you can see how bad it is. Let's still talk about Apache server for a second here, right? This is like something that powers the web a lot. So how do you attack it? Like we said, pretty simple, like I showed you before. You need to fire an HTTP request. So here is how you do it. I think this is the actual payload, so like, very close to the truth. And if you're thinking, oh, Liran, you probably hang out in like dark web areas where people give you that payload. And some people are like nodding here in the back. They're just like, yeah. No, exactly. So yeah, I go to the dark web. It's darkweb.com. And there's where I find everything. Maybe not. So let me show you how apparently easy this information is, right? Like it's very easy. It's on Twitter like everyone else and everything else. That's like where the payloads are. This payload actually referenced in this tweet, which you could like, I can later give you the reference or you can find it. But essentially it does more than just a path traversal attack for that specific CVE. It actually exposes sensitive data that escalates this vulnerability to a command injection, which runs the Linux ID command as a proof of concept. So yeah, that's not really what you want happening, but it does happen. Not only that, but essentially what's happening is also the fact that you are able to kind of like fingerprint and find those vulnerable web servers or application servers or whatever you kind of like want to find on the internet using really open tools that are available to people there, right? Like Greynoise and others that could actually like tell you, hey, you know what? I just fingerprinted some servers on the internet and they're running this and that versions of the Apache server, and maybe they're vulnerable, which is not something you want happening if this is your server, but this really is happening in real life. realized. Let's talk about how to do it right. Like what is the actual secure coding best practices here? Well, one of them is decode URI component goes first. You basically want to decode the URL and change it from one thing to maybe something else. The other thing that you might want to do is to path normalize it, and then potentially maybe you want to source out. Like, this really depends on the application logic itself, but you probably want to like join several paths if you need to like concatenate or structure one path in a secure way. Maybe you want to check first if there's like a relative path that exists on top of it. Like, you want to make sure that one directory sits inside the hierarchy of like another directory. Like, those kind of things are important, and there's like a secure way of doing them and how to use those APIs. Okay, yeah, let's see. Ryan, what do you think so far? Enjoying JavaScript secure coding?
Oh, you were talking about JavaScript. Sorry, I was at the toilet.
Gotcha.
Maybe it's now, and I'm kidding. I think this is something that is not specific to JavaScript. Like, you see this in so many different languages, and we should be aware of, like, path traversal nowadays is one of the biggest ones in many ecosystems, because it's relatively easy to either escape it with a percent notation, or in some cases just doesn't get checked because we're not aware of it. But these practices are something that we need to be aware of as developer in general, I guess. So this is a really very good point, because I think a lot of these things are straight up from demo code or tutorials and in the end, if you misuse these things, it goes wrong.
Yep. Oh, totally. I want to tell you a different aspect of like basically secure coding conventions and how they actually apply, not just to your own code or like your libraries, but actually like think about it from like a different perspective as well, which is sometimes your runtime could actually be vulnerable to as well to like several things, but essentially also like path traversal vulnerabilities, which actually happened in Node.js. So this is like a version of the runtime which happened, to be released a while back. But also, if you've been like tracking, Node.js security releases, like you're seeing, about at least half a dozen of them happening throughout the year, if not more. And like the many thanks and recognition and appreciation should be sent here to like volunteers working on the Node project and the Node release and the Node security team to essentially ship out those security fixes, because it's not an easy thing. But from the consumer endpoint, what I want to say is you should be aware that your runtime might be vulnerable.